Welcome back. My name is Martin Becher, and today we will perform a stepwise approach to assessing climate risk. And for this, let's assume that we have already constructed a dam and we are now in the maintenance and operation phase. We have a concrete dam within a very nice green valley, which provides water and energy to both the village that is nearby and to the outside world. In this context, our system of interest is everything that you are seeing here, both the dam itself as well as its different components: the reservoir, the crest, the spillway, and the pipe for overflow water. When we start our assessment, the first thing we do is to look at the climate variable that may influence our system of interest. So, are we talking about increase in temperatures, about strong winds, about changes in rainfall patterns? Once we have determined about what we are talking about, let's say in change in rainfall patterns, we need to decide whether our system of interest and the different dam components are exposed to that or not. If that's the case, we have to perform as a next step a so-called sensitivity analysis of each component. So, is the crest tentatively sensitive to extreme rainfall, leading maybe to an increase of water pressure? And not only look at the infrastructure itself, but also at the root causes for, let's say, increase of the water level. Meaning root causes like, in this case, the topography of our valley, the soil, but also the ecosystems that are, let's say, influencing water intake or not. Of course, it's also amazingly important to understand the thresholds that guide our infrastructure. Which water pressure does our dam withstand against? And when, in which situations are these thresholds critical? So as an example here on the left hand side, we have the spillway, and if we analyze floods, the design load is for 550 meter per second. However, the normal capacity is much lower. Of course, the design load is designed for usually extreme events. However, due to climate change, these extreme climate events might become more likely and they might surpass the threshold. And in order to understand which thresholds become critical under which situation, we need to analyze different climate indices and analyze under which situations, climate-related situations, which thresholds become critical. And once we know which climate indices are critical, we need to analyze existing climate data and assess existing climate services in order to understand if climate indices are likely, unlikely, or maybe even highly likely to be passed in the medium or long-term future. And for this, we have to look into the so-called return period of critical climate events. Some climate events nowadays maybe only occur every 50 to 100 years, but in the future they might occur much more often, maybe floods every 5 years, so that the likelihood for critical climate events is increased. And as already discussed, it is not easy to look into the future. We have always to work with assumptions about how the future will look like, but we need to know if a hazard that we are currently trying to study is likely or is completely unlikely to happen. Because if it is completely unlikely, the whole exercise doesn't make so much sense. And for this, there is a method of so-called expert judgment, where we jointly together with many different experts assess if in the short, medium or long-term future, the likelihood or probability for a hazard is negligible or maybe even approaching certainty. And this can be done by applying a quantitative method like the method B, or a qualitative method like method A. And applying expert judgment, we are able to put a score between 0 and 7, which will be important for the next steps to come. Once we have assessed the sensitivity, we proceed to the next step, which is the adaptive capacity. And remembering, adaptive capacity are resources to offset risk in the future. So we assess issues like social behavior, financial resources, knowledge, and technical resources, both what we have and both what we lack, in order to map different factors leading to an increased or reduced adaptive capacity. The next step is to assess vulnerability. And if we remember well, vulnerability is when we cross both sensitivity and adaptive capacity. For instance, we have here a matrix, and if we assume that our assessment of sensitivity is that on a scale from 0 to 7, we have a sensitivity of 4, and our adaptive capacity is not very high, let's say a 7, we cross both and we come to a 28, which translates into adaptive capacity of 5. When we talk about vulnerability, it's also important to talk about ecosystem services. Ecosystem services are services that ecosystems provide us in order to enable us to have a good and healthy and safe life. These are so-called regulating services, which, for instance, regulate water flow, supporting services, like the support of everything in the world, life, soil, etc. Provisioning services that provide us with food, with fuel, with water, and also cultural services that we need for our cultural well-being, our mental health, our leisure, etc. And these ecosystem services can help us to reduce vulnerability if they are well available. Let's say if we have a healthy ecosystem in a river basin, the regulating services are well in shape, water flows can infiltrate better the soil, and the likelihood for an extreme flood event is reduced. However, if ecosystems are not in good shape, the lack of ecosystem services provision may lead to an increased vulnerability. For instance, if we do not have a good infiltration capacity because our ecosystems are eroded, the likelihood for increased erosion, decreased flood control, and therefore the likelihood for hazards like flood is increased. Based on the vulnerability, we are able to detail different consequences of a hazard to the different components and to our whole system of interest by analyzing impact chains. So let's say if we have a hazard, there is more water intake, the lake increases, the water pressure on the dam increases as well. There might be a damage and there might be consequences in this area as well. So we may say that vulnerability relates also more or less to severity. We had said that vulnerability and therefore also our severity was a 5 in our last example. When we assess from step 4b, the probability or likelihood for an event to happen is, let's say, quite high, let's say 6, and we had a calculated severity of 5, we cross both again, we come to 30, and 30 is a medium risk, which we need, of course, to address. That was a very quick exercise trying to show you how such a risk assessment can work. I hope you enjoyed it. Thank you very much for your attention and talk to you soon again. Goodbye.